All right, so this video is going to cover the topic of real numbers. In seventh grade, you talked about just the rationals. The set of real numbers will include rational and irrational. So here's what the topic is. Today I'm going to extend previous knowledge of sets and subsets using a visual representation to describe relationships between sets of real numbers so that I can classify real numbers. I'll know I got it if I can analyze a set of real numbers to determine the correct subsets. Our essential question, what are the different types of numbers and how do they relate to each other? All right, so this video is actually in the lesson, so I'm not going to spend time on that, but it talks about the two subsets of rational numbers and irrational numbers. And just to go into more detail, here is the rationals over here, irrationals here. So the set of rational numbers includes our natural numbers, which is just like counting numbers, 1, 2, 3, and so on. Whole numbers include the number 0 plus all the natural numbers. Integers include all the whole numbers and natural numbers plus all the negative numbers. Rational numbers you have to be able to write it as a fraction, but it also includes the integers because you can put a 1 under these and it is a fraction in the form of a over b. And then you have the whole numbers and rational numbers are all part of this. What's different here, these irrational numbers are decimal numbers that gets continue on and on and on. There's no end to them. They don't repeat, they don't terminate. Decimals that repeat or terminate are included over here. So let's break it down a little bit more. So our natural numbers, just defined by the counting numbers, are all positive and you start with 1. 0 is not a natural number. You can pause this at any time if you need to take notes. Set of whole numbers include that 0. So this is the natural numbers or counting numbers and then the whole numbers. So you have they're embedded, so all of the natural numbers are also whole numbers. What's an integer? It's a set of numbers that includes whole numbers, positive numbers, and negative numbers. And here's a number line to show you the integers. Rational numbers, so it's the set of rational numbers, all numbers which can be expressed in the form of a over b, where a and b are integers, b cannot be 0. So here's some examples. And all of these can be changed to decimal numbers. So this would be 0.8, this would be repeating 0.3, but those are rational numbers because they repeat or terminate. All right, here's that group that is new for 8th grade. Irrational numbers, numbers that cannot be represented as a simple fraction. Decimals never repeat, they never end. So pi is that number keeps going on and on and on forever. And then you have square root of 2. So let me just show you on the calculator what the value of square root of 2 is. So if I put the square root sign and 2. Now the calculator will only hold so many decimal places, but see, it doesn't repeat in any way, and it's going to just keep going on and on. So that's why this is an irrational number. These two are examples. All right, putting it all together again, real numbers, no irrationals are rational numbers. They're all by themselves over here. And here's just some more examples. Then you have these the rational numbers, and then you have all subsets. So remember, here's their natural numbers. All natural numbers are whole numbers. All whole numbers and natural numbers are also integers. And all natural whole numbers and integers are also rational numbers because they're embedded in there. Okay, but not all rational numbers will be they're not irrational. Sorry, I misstated that. All right, so let's go on. So let's just check this real quick. It might have more than one answer. So 3/5, is it a whole number? Whole numbers are 0, 1, 2, 3, they're not a fraction. So this would be a no. Hold on, get my pencil. Not that one. Natural number, no. Is it an integer? No. But it is a rational number because you can write it in the fraction form of a over b. -2 does not include negative numbers for whole numbers. Natural numbers do not include negatives. It is an integer. It's also a rational number, so that has two answers. This is a decimal that repeats. You can see 1.45, the 45 repeats. It's not a whole number. It's not a natural number. It's not an integer, but it is a rational number. None of these are irrational. These are all rational numbers. All right, let's look at some other examples. So here you have a subset of real numbers represented in a Venn diagram. To which subset of real numbers does 12 belong? Well, 12 is a whole number. So I'm going to write it in there in the yellow circle. It's going to be kind of small. So it's also an integer and a rational number. So it could be A, but this says only. This says rational, integer, and whole. Whole, integer, rational. That's correct. It includes all three of those in this diagram. The subset here says to which subset of real numbers does -3 go? It's a negative, so we put it into the integers. Now there's only the pink and the blue now, which is integers and rational numbers. It's not A, it's not B, it's not a whole number, it's going to be D. It's a rational and an integer. All right, so this was a STAR question a couple years back. It says, which Venn diagram correctly represents the relationship between rational numbers and irrational numbers? Remember, looking at this, irrationals, there is no overlap here. Okay, so no irrationals are rational. So look at this one, they're totally separate. This says because rational numbers and irrational numbers have no numbers in common. That's the answer. They have no numbers in common. Oh, I changed to the highlighter. Whoops. All right, so this was a STAR 2023 question. It says a Venn diagram shows a relationship among several sets of numbers. Where should -169, square root of 169 be placed in the Venn diagram? Well, let's use our calculator and see what the value of that actually is. So it would be a negative square root 169. So the value is -13. So -13 is an integer. It's not a natural number. It's not a whole number. So I'm going to go ahead and place that into this box. And let's look at our statements. A, rational numbers because it does not equal -85.5. Next one, okay, integers because this is true. This is not true, and that's not true because that's positive. So the answer there is B. All right, so that is the last one. Hopefully you understand. If you need some more help, just reach out to me. Thank you.